Delicious meal and the fascinating demo showcase. Now let's transition to our next exciting segment, the hands-on AI workshop on the latest Intel AI product portfolio and generative AI performance optimization using Intel One API on Intel Developer Cloud. May I once again request everybody in here to use the login credentials that are up on the screen and just get started? Are you all ready? Everybody's logged in? All right. I'm sure all the developers in-house have been eagerly waiting for this session. So without further ado, let's give a warm welcome to Anish Kumar, AI Software Engineering Manager, APAC Intel, to please come up and lead this session. Ladies and gentlemen, give it up for Anish.
So good afternoon, everyone. Am I audible, everyone? I think it's audible, right? And I think you all had a very nice lunch. It's sleep time, but I'll try to make my presentation interesting. And there'll be very exciting, nice hands-on workshops on some of the latest generative AI models. So let's start with that. So before that, some standard notices and disclaimers. If you, most of you, I think everyone is aware of ChatGPT, at least they would have used, or at least you have heard of ChatGPT. And if you see the trend, how these generative AI models are coming up over the years, when ChatGPT 1 was officially released, it was around 175 billion parameters. That was the total parameter size of a ChatGPT 1 that was released for the public. Then over the years, Megatron came, it was around 530 billion parameters. Now there's a ChatGPT 4, which is 1 trillion parameters. So we are all trying, we might get hyped with all these billion parameter models, all these numbers, hi-fi numbers, right? The billions and billions of, now we are getting to trillions also. It's more than a trillion now, ChatGPT 4. And when enterprises start thinking of deploying generative AI models in their use cases, they start thinking that they might want to use, say, ChatGPT 3, 175 billion parameter, or maybe a ChatGPT 4, which is more than a trillion parameter, right? But when you actually investigate or try to do more research, what does this 175 billion parameter has? 175 billion parameter model that was released in the first ChatGPT, it had all the data from human history, right? From the beginning of human history, all the written records from the beginning of human history that was there on the internet, from there till I think 2020, mid of 2020 is what ChatGPT was released. So all those that open data that was there, it took all those data and they trained it and they created a model called ChatGPT 3. So if you could include all this from the beginning of human history till mid of 2020, all the written records that is publicly available, if you can take it and put it up in 175 billion parameter, then you need to also introspect and check when you're actually building for an enterprise. Say, let's say if I'm building an LLM model for Intel, right? So Intel was started in the late of 1960s, right? And it's hardly some 60 or 70 years old company. If I take all the text data that Intel has generated in this over 70 years, it might be hardly fitting maybe in a 1 trillion or 1 gigabyte or 1 terabyte, maybe maximum 1 terabyte. If you compare the amount of data that Intel generated in the 70 years of its existence to the entire human history, right? You don't need a huge models. You don't need 3 billion parameter model or a 10 billion parameter model. What I'm trying to convey here is, when you're having an enterprise use case, don't try to think of using huge models, right? You can begin with a smaller model, like maybe a transformer model, maybe a BERT model with 340 or 500 million parameters, right? Use a smaller model, then we can do the fine tuning. So how many of you are aware of generative AI models? Okay. And how many of you have used, like heard of Llama 2, Falcon? So before actually then, I think some majority of them don't know what generative AI models are. So probably I can give a brief introduction of generative AI models, right? before the advent of generative AI models, we had a AI, we had the classical AI ML. What the classical AI ML used to do is, it used to take some certain amount of data. Say, for example, I can take 10 years of weather history. I can train a model and use that model to predict what might be my weather condition, say, in the coming April, right? I can take Bangalore's 10 years weather history, and maybe I can take the climatic conditions, the pollution level and everything, and then probably I can ask the model to give me a prediction on what might be the potential summer in April, right, in Bangalore. Or maybe I can actually deploy certain AI models maybe in this conference hall, and I can say like automate the air conditioning based on the number of people. It can actually recognize how many people are here, and based on that maybe it can adjust the air conditioning, right? So all these AI models, or maybe it can be a predictive maintenance in the factories. Maybe they might have a machine. The machine can be, the data from the 10 years of working of that machine can be taken and can be trained. And then you can actually do a predictive maintenance. Instead of doing a periodic maintenance, what you can do a predictive maintenance when the machine can potentially fail, right, based on the sensors input. So all these kind of classical AI ML didn't really impact skilled workers. Like I'm assuming everyone here are at least are from the engineering background, right? Or if you are not from the engineering, at least you are from the technology background, right? So most of this AI ML didn't really impact skilled workers like you and me, right? They used to usually happen either in the factories or maybe somewhere some it's not necessarily available for the larger general public. But with this advent of generative AI models, how does it differ from the classical AI ML is, generative AI models can actually generate brand new data that never existed. What the classical AI ML used to do is it can only generate data that is already there. You have a data, you can do a permutation and combination of those data, and it will give a prediction kind of thing. But generative AI model, given a query or given a situation, it can actually generate a brand new data that never existed in this world, right? Say, for example, how many of you have ever heard of DALI? Okay, so for those of you who are not aware of DALI, DALI is actually a generative AI model that can actually generate a brand new image for a given text. You can give a text like, generate an image of a man riding a horse on Mars. So there never existed a situation where a man was riding a horse on Mars. But if you give it this text prompt, it can actually generate an image for you. Or for ChatGPT, you can ask ChatGPT any questions, like probably many of you would have tried. Maybe you have to write your emails, to write your profiles, or you can ask any query to it. It can actually generate data for you. So this is how generative AI models differs from how the classical AI ML. Generative AI models can actually generate data from what it has learned, and those can be from the text data, like these LLMs, ChatGPT, Llama, Falcon, Mistral. These are all different types of large language models that can generate text. You give a text, it will generate a different text for you. Then there are Stable Diffusion, DALI, and other models that can actually generate an image for you. Like you give a text description and it can generate an image. And then there are newer models that are coming that can actually, like I think many of you have heard of Soros. Have you heard OpenAI Soros? That was recently in the news. It can actually generate an entire video sequence. You give a description of the video sequence, what exactly video you want. It can generate an entire video for you, right? And then there is a model called Imagen. Imagen is also a model from Google that can actually generate an entire video sequence. Then there's a model that can generate music for you, or it can generate a voice. It can actually take over my voice and actually can replicate the voice. It can do that. So what these things are doing is they are actually venturing into the creative industry. All these industries are creative industries, right? Generating music, generating text, generating video. These are all very creative industries, skilled industries, right? And these generative AI models are slowly venturing into the skilled industry. There are generative AI models that can write code for you, right? Maybe in another 1 or 2 years, there's already tools that can generate very good code, but it can still mature to an extent that most of the developers' role can become irrelevant, right? It can generate, you give a situation, right? Write me a Java code to implement a login feature for a JSP servlet. So it can write a code in seconds. Instead of a guy taking some 2-3 days or 1 day to write a code, it can write this entire code with a complete syntax, with all the comments and all the test cases. It can even write a test case for you, including the automation of part of it. And this is how it's actually helping you automate. Then the question, immediate question that comes to everybody's mind is this generative AI model going to take away our jobs? We are all paid heavy salary, and now the companies might tell, okay, let's remove everyone, let's have one generative AI model, and we can have a product manager, he can write a description of it, feed that description to the generative AI model, it will generate a huge code, all the software is automatically generated. Probably that scare is too far-fetched. If you see the past history, how it happens is, generally whenever a new technology comes, those new technology will obsolete the older ones, and the newer roles will come in, right? The one classical example is the banking industry. In the early 90s, when the banking was not yet computerized, what used to happen is people, there maybe in entire Bangalore, there might be like 20 or 30 bank branches available in key areas, and you might have to stand in various queues and things like that. And when computerization was introduced, people used to say that the computers can actually take away the banking jobs, right? It can take away banking jobs, and it can reduce the total manpower requirement. But if you look back now, 30 years after that, it actually increased the total number of employees who are employed in the banking industry, right? So earlier, instead of having totally 25 banks in entire Bangalore, now we have 25 banks probably in this 5-kilometer radius itself. We have ATMs, we have everything, right? It's all automated, it's all connected, it's all centralized. And the number of, probably, if you do a rough estimation, if earlier, if it was like, say, 10,000 bank employees were serving in Bangalore, now probably maybe like 5 lakh people might be serving only in Bangalore alone. So the number of job employment has actually increased. But what was the change? The change is the skill set of the people who are working in the banking has to be upgraded. So what I will say is, we developers probably we need to keep upgrading. There's a competition coming for us in the form of generative AI. It's not only for us, it's for everyone. Be it, say for example, somebody is generating a music, right? Say A.R. Rahman or some famous music player. It's actually going to give a competition for them. But that doesn't make A.R. Rahman or other music directors irrelevant. It will actually kind of make their work more easier, right? It will help them actually, instead of spending, say, 1 week to create a song, you might actually take 5 minutes to generate the music and probably invest another 2 days to improve the music, right? So that way our productivity increases, and maybe like there will be more musicians on the way, and that will actually only help you improve. So everybody had to upscale, right? So I will say, don't worry about job loss. I'll only say you have to keep upgrading, keep updating yourself, right? Learn these new technologies. See how you can actually beat this, the code that is generated by an LLM model, how can you beat it? See how you can detect errors. What are the potential things it can actually, where are things potentially it can fail. For those things, you need to know how this actually works, how these large language models work. So you need to understand how the large language models work so that you can actually find fault in these things. So with that, if I go to the next, you need to also see the total cost that is involved in generating this kind of models, right? If ChatGPT 3 took almost close to $2 million, ChatGPT 4 it's around $40 million, the Bing AI chatbot took almost $4 billion. It's not only the dollars that is huge here, it's also the amount of computing power, the amount of energy required to create all this kind of huge models that can actually transform. Maybe this kind of will be new kind of a technological revolution that is happening, that we are witnessing. We are lucky to witness this kind of a new revolution that is happening, right? So if you see, this is the cost that is involved. And if I ask, say, any company to build a model, probably it's not practical enough for everyone to invest $40 million or $4 billion to build a model that is so powerful, right? So what is the alternative? The alternative is use a smaller model, like say for example, Bloom 500 million model. That's a very small model. You don't need huge computing power. You can take just one Xeon with say 64 GB of RAM or something, and you can actually fine tune that model to industry specific. Let's say, for example, this particular person is working in healthcare domain. He can take all the healthcare data. Maybe the healthcare data hardly it will be, say, if you take all the healthcare data that is available in a textual form, it might be hardly maybe one gigabyte, maybe maximum 100 gigabyte, right? In the text, if you take the text files, feed the text files, fine tune it. How many of you are aware of what is fine tuning a large language model? Okay, very few. So fine tuning means basically there are open source models like the Llama 2 or Mistral, Bloom. These are all open source models that are available. Like they range from 500 million parameter model up to say 70 billion, 170 billion parameter model. What you can do is you can take a smaller model. Smaller model means the intelligence embedded within that model is very less, right? What you can do is you can take the data that you had from your specific industry. Say if you're working in healthcare industry or an automotive industry, take that data, add that additional intelligence on top of the existing model. So take this 500 million model, add the intelligence on top of that. And you can do that intelligence right on your, you can actually use even your laptops. You don't need a powerful machines to do that. Only in laptop it might take 1 or 2 days to finish the fine tuning. But if you have a powerful processor like a Xeon or something, it might take 30 minutes to finish the fine tuning of it. So with that, what you can do is like you can build models that are specific to specific industry. Say for education, healthcare, finance, retail, government, or energy. Build models that are specific to those specific industry that are very lightweight, and deploying it is also very cost effective, and the kind of answers that you get from those models is also relevant to the industry that you are working in, right? And I was telling you about the fine tuning. So generally what happens in the first thing, if you have say, this is about the ChatGPT exposes their API. You can use the ChatGPT APIs. You can also do retrieval augmented generation. So there are two ways you can add intelligence to an existing model. You can do a fine-tuning job. Fine-tuning is a compute-intensive job, and it's not real-time, right? So you take, say, once in a month, you might collect all the data that is available with you. Take that and do a fine-tuning job and generate a new model, deploy it to production, and start using it. But if you have a use case where you need to have real-time data. Let's say the real-time data is stock price. I want my model, my generative AI model to be intelligent enough to know what is the latest Intel stock price on a given date. So you can actually use retrieval augmented generation technique to allow the model to connect to internet, fetch the latest stock price of Intel, and maybe all the news related to Intel's business activities, so that if somebody queries, tell me how is Intel's business looking for, then it actually can go to the some news aggregate website, pull up all the news related, or maybe it can go to Intel's website and pull up all the latest news, and then can summarize those news for you. So this happens in real time, right? You can implement a RAG implementation. It's called, in a short form, it is called as RAG. You can implement RAG wherever you have a real-time need for updated data. But if you don't have a real-time need for an updated data, but you have a huge data to begin with, you can take those data and do a fine-tuning job instead, right? And then build smaller models that are specific to specific industry, like the finance chatbot or a code generator, or maybe like a clinical notes transcription or something like that. Then we have the open source models like Llama 2, Mistral, and these are all open source model. Anybody can download. Everybody can sign up for it and download those models. And you can also implement fine-tuning and RAG on that and generate these models. What I'll personally recommend, probably you can use those open source models. It's very cost effective. And the only resource that you might have to spend is your brain power and some compute resource that you need to implement all these things. And it's very cost effective in terms of actual cost of deployment. Now coming from the Intel's perspective, Intel's AI perspective, right? Intel has been playing the role in all these verticals, right from the hardware level to the actual application deployment, right? So if you say, how do I streamline the entire AI workflow? We have for the training of a new model, or for fine tuning, or for deployment, we have different software technology as well as hardware technology stacks available for the developers like you and me to actually use this to enhance our productivity. If I get into the details, for training, we have all these open source libraries and framework, right? How many of you are aware of PyTorch, TensorFlow, NumPy, SkyPy? Yeah, vastly majority of you know. So for those of you who don't know, these are all actually frameworks and open source frameworks and libraries that will help you get started easily on building an AI pipeline. It can be a classical AI ML, or it can be a generative AI model. PyTorch and TensorFlow is mostly for deep learning or generative AI models, but other libraries will add a lot of, it will ease your workload in terms of processing the data and things like that. So what Intel does is, Intel actually invested its resource in trying to optimize all these libraries so that you get best performance on the Intel hardware. Say, for example, there is Pandas library, which actually helps you process all the data. You might have a data in the form of CSV or something like Excel or something. You can actually use Pandas to process that. And what Intel did was, Intel invested a lot of engineering effort in trying to optimize it, and released an optimized version of Pandas called Modin. And with just 2 lines of code change that we will do it in as part of today's workshop, you will see that you will see a tremendous boost in performance. And how does the performance boost happens, right? Generally, when these open source models are released, they are not optimized for specific hardware. They generally take the common features that are available in a hardware and try to implement those workings of that particular libraries or tools. For example, Pandas, even though if most of your systems might be like dual core or quad core or octa core, or they might be like 20 cores in your machine, right? But Pandas generally uses only 1 core. Even if you have 4 cores in your machine, it will use always only 1 core. It never uses the other 3 cores. And it will be, these 3 cores will be idle. And that translates into the slowness of your application, right? And when you're comparing to generative AI models are generally running into gigabytes. You might have a 1 gigabyte CSV file, and if you have to process it, even though you have a compute power, you will not be able to utilize those compute power. And with 1 line of code change, you can introduce Modin. Modin is an optimization done by Intel on top of Pandas. You can actually change this entire performance drastically. There are instances where you see 10x improvement. How does this magic happens? Modin will ensure that you are actually parallelizing all your activities on all the available cores. You might have 10 cores. Modin will go and utilize all the 10 cores so that your performance, suddenly you see there's a drastic increase in the performance. And then there is a PyTorch. So Intel has an extension of PyTorch called Intel extension for PyTorch. What it does specifically for high-end data center processors like Xeon is, the latest Xeon processors have specific accelerators for specific workloads. Like for the AI workload, they have an accelerator called AMX and AVX. And Intel extension for PyTorch, what it does is, it just with additional 2 lines of code change in your existing code, you can actually make your code to utilize all these specific features available on your hardware. So if you have any questions in this specific thing, any tools, if you have any questions, we can discuss. Feel free to interrupt me at any point if you have any questions on any of these things that is flashed here. So basically, the summary of this slide is, you have a lot of tools and libraries that Intel keeps optimizing it and help you bring those things to you for free. And then from the point of infrastructure, we have both from cloud to client, right? Intel has been a player for, like we have the Xeon or the Max series of GPUs for the cloud and the data centers, and then we have the Core series or the Meteor Lakes that is on the client side. So it helps you basically deploy your AI models at a different, based on the kind of need that you might have. You might want to, if you have a very small, simple model, you can deploy it on your local laptops. But if you go to the booth, the demo booth, there is actually a very good demo on how you can actually run an entire speech transcription and speech diaration using a Meteor Lake processor. It's a client-side processor running on a laptop with the 32 GB of RAM, and it's using all the latest generative AI models to do that. So you could use that, or if you have a very high-end enterprise application, then probably you can use the Xeons on your cloud to achieve large-scale deployments of compute-intensive workloads. So from a hardware perspective, we generally recommend to use clusters of machines for training. Training is a very compute-intensive job, especially for generative AI models. The training is usually takes at least even for a smaller model, it might take a couple of days to weeks. And if I remember correctly, the ChatGPT 3 took almost more than 6 months with 16,000 GPUs running. 16,000 GPUs running for more than 6 months generated a 175 billion parameter ChatGPT model. That's the amount of compute power that was required to generate that ChatGPT 3. ChatGPT 4, definitely we don't have the numbers exactly, but definitely it will be at least 10x what we see with the ChatGPT 3. So what it actually implies is training is a very compute intensive job. So you might have to use a cluster of CPUs, GPUs, or AI accelerators, like Intel has an AI accelerator called Gaudi2. So Gaudi2 is specifically meant for accelerating your AI workloads. It's not exactly like a GPU, but it's a specific accelerator for mainly for the AI jobs. Or then you can use multi-node deployment. If you have 100 billion plus parameter, if you want to do an inference of 100 billion plus kind of a parameter model, you can use a multi-node deployment rack. Or if you want to do a inferencing or fine-tuning of up to 100 billion parameter, you can use multi-GPU or multi-socket CPUs. That means you can use multiple max series of GPUs, Intel GPUs, or maybe some 10 Intel Xeon processors to do the fine-tuning or inferencing of generative AI models which are less than 100 billion parameters. Then for 20 billion parameter, you can use a single socket CPUs. And definitely if it is less than 1 billion, like the demo that you see there, you can use your laptop itself to do these inferencing loads. And so these are some of the very specific, probably you might have to just remember those names. For most of you are aware of the core series, maybe ARC. Some of you might be aware. ARC is a series of graphics processor mainly for the client computing like your laptops or desktops. And then you have the Xeons. Xeons are data center CPUs. And then we have the Max and Flex series of GPUs. Again, it's for data center, it's not for client computing. And then finally, we have the Gaudi accelerator. Gaudi is an AI accelerator dedicated for AI workloads alone. This is how the Gaudi looks. Probably we'll get into details of the Gaudi. Before we get into details, so what I'll want you to remember is Gaudi is a good alternative for existing hardware that is available in the market. If you are wanted to do a training or a inferencing or fine-tuning kind of a job, do use Gaudi. Gaudi gives you equal or better performance in different situations based on your workload. And the cost of Gaudi is much cheaper than the currently available hardware in the market. And I'll actually walk you through what are the different tutorials, what are the different materials available for you to actually learn about Gaudi AI accelerators. Some of the key things that you might be learning is how you'll learn how to access various materials related to Gaudi and how do you migrate. You might already have a model that is developed for say some existing hardware, non-Intel hardware, and you can actually want to migrate those models from that particular architecture to say the Gaudi accelerator. There are tools that are available, so we'll go through those tools and try to understand how to do those things. And also as part of this, I'll show you a demo That's not a hands-on demo, but I'll show you a live demo where you can actually run an inferencing of stable diffusion model. I think that will be pretty interesting to see how a stable diffusion model works and how creative it can get. So the Gaudi accelerator is mainly meant for performance and its ease of use and scalability. How does it achieve that is, it has almost 24 tensor per processor core per Gaudi silicon has 24 TPUs. That's what it's called as. And then it has 96 GB of onboard high bandwidth memory. That particular processor itself has, it's not a processor actually, it's a silicon accelerator. The accelerator has 96 GB of onboard high bandwidth memory. And one of the key interesting factors is it has 24 integrated 100 Gbps Ethernet ports. That means each Gaudi silicon inbuilt has 24 100 Gbps Ethernet cards. Why do you need those Ethernet cards in a accelerator? Because all these AI workloads will never be usually done with one silicon. You usually, minimum you will use 8. That's the minimum that you use. You use a minimum of 8 Gaudi instances. Connect them all through a high bandwidth 100 Gbps Ethernet ports so that there's a very minimal lag in sharing the data. And then if you take it up a 100 billion parameter or a 500 billion parameter model, usually it is like, you might use, like I said, it might be hundreds of Gaudi instances running. So you might want to have, instead of having a separate Ethernet controller, it's better to have all those Ethernet things available within the Gaudi itself so that you can stack them together, it can interconnect them so that they can work seamlessly. So from a software perspective, if you see at the very bottom, there's a Gaudi hardware that is available, and on top of that, then there is a OS kernel and then the user mode drivers. And Gaudi drivers are available on top of that user mode driver, where it's called as Habana kernel library as well as Habana communication library. Basically, all these libraries help you utilize all the features or performance that are available with Gaudi, right? So it is easily integrated with PyTorch. PyTorch, how many of you are worked with or aware of PyTorch? Okay, very few. So PyTorch is one of the open source library for deep learning applications. It will help you quickly get started on doing all these jobs, be it training, inferencing, or fine tuning, or RAG implementation. You can use this PyTorch library so that all the basic jobs of implementing certain features will be readily available with PyTorch. So Gaudi AI Accelerator software is readily integrated with PyTorch. So that's a good thing. PyTorch is one of the most popular frameworks that is available. And it's also optimized with minimal code. You can optimize those your existing code. If you have an existing code, you can actually do with minimal changes, you can actually optimize it to get better performance. How many of you are working on generative AI related use cases like LLMs, image generation? Okay, couple of hands going up. Good, but what we can see is what the current trend in the industry is going forward. You actually see more and more companies, be it small or big, are going to utilize these deep learning models or the generative AI models to a great extent. One specific area where especially the software companies might be using is the code generation. Right? There's a model called Code Llama. Probably it's an open source model. You can download it on your systems and try it out. It generates very beautiful Java code, right? You can give a description what exactly you want to do, or you can write a test case. If you are a person from the QA background, you can describe the test case. It can and give the code that you have. It can write the complete test case, kind of almost foolproof. I don't say currently it's 100% foolproof. Maybe you have to do some bit of review, but definitely it gives you much better code than an experienced person writing for 10 days. It gives you in seconds, maybe 5 seconds or 10 seconds, it gives you the complete code. You review it, you spend the rest of your time in reviewing it and maybe enhancing it, right? You can do that. There are 3 places you can actually start using the Gaudi software along with the Gaudi hardware. Like there's a Gaudi model reference that is available in the GitHub. It's all open source. It's freely available. I'll share the links at the end of this slide where you can actually go to those slides and actually can try out those examples. And there are examples available, a lot of examples available for different, both classical AI ML as well as their deep learning models. You can try them out. Then the popular Hugging Face. Gaudi team has been working extensively on the optimizing the models that are available in Hugging Face to work better on the Gaudi hardware. And then the GPU migration. You might be using a non-Intel GPUs for your AI models. You could actually use a tool called GPU migration toolkit to convert your existing GPU code to the Gaudi tool, Gaudi code in minutes. I'll try to give a demo of running a Gaudi inference demo. Let me see if I can run it. Can I have my desktop screen flashed? Okay. So I already have access. I'm using a Gaudi machine that I have set it up and trying to run that code using Jupyter Notebook. How many of you are aware of what is Jupyter Notebook? Okay. So Jupyter Notebook is a web-based interface to write your Python code in a nice and useful way. You can write your comments, you can write your code, and you can execute line by line your Python code. And it gives a very beautiful interface, which is a simple interface. You don't need any powerful tools to download. Just your web browser is all that is needed to run those Python code. So let's try to see if we can run this Stable Diffusion PyTorch inference demo here. So this is how a Jupyter Notebook will look like. You will have at the right side, you might have an interface to access your files on your system, and on the right side you have this interface to write your code. Some of the things that you might want to know is this play button. This basically will run your cell, the code that is there in the current selected cell. And then there is also a kernel. You need to select the type of kernel. Currently here I have only Python 3 kernel. You can go ahead and select. Maybe in your use case you might have a PyTorch kernel, you might have a TensorFlow kernel or any other types of kernels. So based on the use case, select a kernel and select the cell. I have selected the cells, the blue is highlighted, that is the cell is selected now. I can click on the play button. Since it's all command, it goes very fast. Now here there is a code. I'm actually going into my root directory and trying to clone this particular GitHub repo. Probably I'll share this GitHub repo link at a later stage. Probably you can try it out later. So I'm cloning that GitHub repo. It takes a couple of seconds to clone it, and then I'm going inside that repo. I'm setting certain Python environment variables for running this example, and installing certain requirements that are needed, certain libraries and tools that are required as part of the running. So it takes, it finished installing those requirements. And I'm trying to download the Stable Diffusion model now. This is the code that actually tries to download the Stable Diffusion model for Hugging Face Gaudi. So the Stable Diffusion model is around 2 gigabyte, I think. So it's trying to download. It takes a couple of seconds to download. I think it's taking around 30 seconds to download a 4 gigabyte Stable Diffusion model. The Stable Diffusion model version 2.1 is the one that we are going to use now. So while it's downloading, any questions so far? Probably once you start seeing this demo, if this is small command line based demo, So probably might not be so interesting to see, but maybe after this I'll show you some nice user interface based demo. That will be pretty exciting to see. So it finished downloading the model and it's asking you to enter a prompt. So I'll give a prompt. A green horse on Mars. So I gave the prompt and then let me try to do an inferencing of that model. So I'm giving a command to do an inferencing to generate a 512 pixels by 512 pixels image with the steps. The steps is something that probably you might have to remember. While I'm showing the GUI based demo, probably you'll see, try to appreciate what these steps are. Basically, how a stable diffusion model works is, stable diffusion model will take an noisy image, like completely noise, like just like how your old TV when it doesn't have any signal, it comes full of noise, right? It takes up an image, something like that, and it will iterate through each step to generate an image for whatever the prompt that you get. Say for example, I have given a prompt here as a green horse on Mars. That's the prompt that I have given. So it can actually iterate through each of those steps and to slowly convert that noisy image to the final image that this prompt is expected to generate. So here you might not see the 35 steps in the command line. You might not be able to see the 35 steps. But when I'm showing the other demo, you might actually see that how a noisy image slowly propagates and generates the final destination image that you wanted to see. Looks like it encountered an error. So probably I'll switch to the GUI-based demo quickly and show you that instead of this command line demo. Just give me a moment to set it up. I'll explain what I'm trying to do here. I'm trying to access one of the lab machines that I have. Are you able to see the code here? Probably it's not relevant, so don't worry much about that. It's not relevant, so don't worry much about that. So I'm trying to use an interface called Invoke AI. Invoke AI is an open source tool. Do note it down. And maybe once you go home, probably you can download that. It's a free tool. You can install it on your local laptop. It might be a bit slower, but still you can install it on your local laptop and try out a few of these experiments that I'm showing here.
I have one question.
I'm sure plenty of you will fall in love with this tool. And you might also start using this tool for a lot of your applications, both your personal as well as your professional projects.
Excuse me.
So I'm trying to start the Invoke AI. Sure.
When you're giving any prompt, right? Say green horse, and you are using a noisy image, right?
Yeah.
So what kind of noisy image you are using?
So it's not the image, that noise image I'm using. It's actually stable diffusion will start with a random noise. I'll show you that it's a completely full of noise. Just it looks very.
That's okay. It is a noisy image, but inside the noise there must be some image.
No, it actually there's nothing in the image. There's nothing meaningful in that. It's completely noise, just like how a television without signal looks like. The television screen without signal looks like. It's like that.
No, but it has become noisy after a few steps, right?
Huh? Sorry?
it becomes noisy when you add noise to some image. Then only it becomes noisy.
That is while training, when you're actually
Yeah.
training a stable diffusion model. Say, for example, you would have dumped it with all the different types of images. Say, for example, this is how Mars looks like, this is how a television looks like, this is how a mobile phone looks like. So it will actually take that original image of a phone and then try to see, add noise into that image and see how it actually looks. Right? It tries to do all the mathematical calculations and build up a logic, and that's logic is what you call it as a model. Basically, it's all about mostly matrix. If you actually dig into a model, generative AI model, finally what you see is a correlation between different things. If it's an image, it's a correlation between RGB values and the opacity values, right? All this, there are 4 parameters. If it's a text, and then the correlation is like your, like for example, I'll ask the question is which is the capital of Karnataka? This is the question, right? So now, how does the model will reply that the capital of Karnataka is Bangalore? This is how the model will be replied. But how does it reply? I'm trying to simplify. This is not exactly how it works, but I'm trying to simplify how it actually works, right? It will actually try to give rank for a given question. Which is the capital of Karnataka? The answer has to be the word has to come first. So it will actually take a possible list of words that can come first word it can come. Say the word is rank number 1. Or maybe the Bangalore is the capital. That can also be an answer. The capital of Karnataka is Bangalore, or Bangalore is the capital of Karnataka. That can also be. So Bangalore might be the second word, the word that can come, probability of that word coming with rank number 2. So it will basically rank each sequence of words and give you a rank. And finally, when you see it, it actually comes up as a matrix with a list of words and their rankings. And whichever word that comes with the highest rank, it will take that word and then it will output as the output for you. This is how you can give it in a very simple definition of how a generative AI model works. And this involves complete matrix multiplication, right? So when you're actually training a model, it actually takes all this data and it will rank for given, say for here there's if I take any text, right, it will try to see how these words are occurring, how many times in your training data, and it will give the rankings for that, for each of those words, and then build my matrix. There will be like millions or billions of matrix inside that model. Not only matrix, there are a lot of other things, but the main component is matrix. And that's where the AMX Accelerator that is there in Xeon, it will help you fasten. All that is happening when you give an inference to an LLM model or a stable diffusion model, all that is happening is majority of them is matrix multiplication is what is happening, right? And it does the matrix multiplication, tries to generate the final output. For your specific question, for the inference, it starts with a random noisy image. There's no random noisy image, and then it actually iterates to your prompt. There is a text encoder which takes your text input and converts that text input into a vector image. Vector is again basically a matrix. Basically, it will generate a matrix representation of what your prompt is, and then see for this particular matrix which was the closest image that was represented in my training image, right? So it will try to map it. I'm trying to simplify it. I cannot explain it completely in details, but I'm trying to simplify it. Then it maps it. Then it takes piece of that in first iteration. Then again it goes through the second iteration, and every iteration keeps improving, and you see these RGB values slowly changing over time. Probably when I show the demo, you'll be able to see how the magic happens from a random noisy image to the image that you actually wanted. Just give me a moment, I'm launching the user interface. What I'm doing here is SSH, it's called SSH tunneling. I'm actually having a server that is located in one of the Intel labs, and I'm initiating a server on a particular port. 886777 is the port where I have initialized the server. And I'm trying to redirect all the requests that are coming to that particular port from on that server that is located in my Intel lab to my local machine on the local laptop. And that is called SSH tunneling. That's the command that we use for SSH tunneling. That's a pretty common command. Probably you can Google up and try to understand that. So I'm saying localhost colon 8877. It actually tries to infer that the server is running on my local laptop, but due to SSH tunneling, actually the request is going to the server that is located in the Intel labs. Taking some time to load. Meanwhile, any further questions while it loads? Maybe that's a lab machine, somebody else is running some job on those machine and it might be busy with that. Let me see if any other job is running on that machine. Yeah, it's slowly loading. Is the internet good enough? Yeah. So this is how the interface looks for the Invoke AI. Do you download it? It's an open source. Just Google up Invoke AI. You should start getting this interface. And the prompt I gave to generate this particular image that you are seeing here is basically I gave the prompt as an hyper-realistic avatar of a guy riding on a black Honda CBR 650 in a leather suit, high detail, high quality, 8K photorealism. And maybe let's try to generate one more image. I clicked on generate, so it starts preparing the model. I'm trying to use the stable diffusion one. So here you see this is the noisy image it started with. And slowly go iterating through the steps. I have given the total steps as 10 steps here. So it goes through, iterates through the 10 steps to generate that image. And all the images that you see on the left side is all the images that is generated by the stable diffusion model. Images that never existed. The tiger image that you see never existed. It actually generated that out of computation. So you can see that noisy image is slowly getting converted into the image that finally you wanted. While it generates the images, I'm actually using stable diffusion 1.5 version here, but there are also many other models like OpenJourney. OpenJourney is kind of an alternative. OpenJourney is an open source model, which is kind of an alternative for Midjourney. Midjourney is a paid tool. How many of you have used Midjourney or seen Midjourney? Okay, one or two examples. Do see, go and check out Midjourney. It's very good in generating some of the images. The kind of images it generates is pretty mind-boggling. So this is the image finally generated. Anybody wants to give a try? If you have any prompt, you want to give a try? I'm changing the model. Maybe I have few prompts with me. One of the prompt is Bruce Lee in a dynamic martial arts pose, street art style, energetic and powerful mood, graffiti spray, paint lighting, vector graphic and white background. Let's see how this image turns up. Again, it started with some random noisy image. It started generating the image that the prompt that you gave. I'm not sure if it exactly looks like Bruce Lee. Hopefully it will look exactly like Bruce Lee. Yeah, do play around. It's all pretty interesting images it has generated. Based on the model in which it was, it can also help architects, right? If there are architects, and if you are designing your home, you can instead of going to an architect, probably can ask this stable diffusion model to generate a 3 BHK architect plan, exterior plan for you. It can generate a nice exterior plan for you. Yeah, this is pretty good image for stable diffusion model running on a single socket Xeon CPU. Anyone wants to try anything else before we jump into other things? Okay, can we switch to the slides back again?
Excuse me? This way. We can give any prompt, right?
How can we?
Like you said, we can give any prompt that.
Can you keep your mic closer?
Yeah. Like you said before, Lee, that we can give any prompt that never existed in the real world.
Yes. Let's try that out, right? We can try out like a astronaut riding a horse on Mars. You're sure, right? There's never an astronaut riding a horse on Mars. Yeah. So we could try that out and see what the output of that prompt.
Or else I also have a prompt.
Sure.
Like a guy riding a shark.
Guy riding a?
Shark.
Shark. Let's try it out.
I have one more question.
Sure.
Now we are using English, right? As medium for prompt.
Yeah.
Is it possible to give a local language, vernacular language?
So that's a very good question. So all these models that I talked about so far is all English. Maybe they might have a little bit of French or German, but very little. But the Indian government has been taking very good initiative. Not only Indian government, some of the startups within India have been taking very good initiatives, and they are actually starting up with developing models for the local language. I think Bhashini was released some 1 month back by the Indian government, or maybe some startup started up. What they did was they took all the Hindi, I think popular some 3-4 languages, Hindi, Gujarati, Bengali. I'm not sure. Hindi is there for sure. I don't know what other languages are there. But definitely this is the new trend, especially for the Indian market, where companies are developing large language models for the local language. So you can actually maybe another 6 months or 1 year down the line, you'll see a lot of models that can actually interact with you in the local language.
Thank you.
Can you switch back to the screen again? An astronaut riding a shark, was that your prompt? A guy. A guy riding a prompt, and I'll add some additional, maybe an hyper-realistic guy riding a horse. Let's see how what it generates. We can already see shark is in the picture, but let's see whether the guy is there. You can get creative, you can give even something more impossible things, right? Like a guy riding a shark on Taj Mahal, on top of Taj Mahal. So it's iterating through 10 steps and trying to generate an image of 512 by 512. It's running CPU.
I have another question.
Sure.
Like as the image is processing, so is there any chance that we can see like how many percentage it has been like processed? Like 30%, 50%, like it starts from
You want the progress? You want the progress?
Yes, yes.
Yeah, but progress is definitely available. Currently, here I'm not showing you the progress. If you go to the console, let me see if I can show you that. Okay. Yeah, it generated the image for you. Yeah, this is actually the progress. Let me try one more thing. Any other prompt you want to try? Anyone? Have the mic.
So, a common man trying to solve a water problem in Karnataka. Yeah, I mean, you can add more flavors to it, but we want to see what are the different solutions that person will come up.
No, that probably might be a question to an LLM model. This is basically generating an image.
I understand, I understand.
Let's see what it generates.
Sure.
That's an interesting prompt. Okay, we have a common man here. I don't know whether that man really exists in Karnataka. And yeah. So here, mostly the CPU might be maxed out when it's actually happening. Most of these generative models consume heavy compute, so mostly it's 90% and above. So there's a common man, I think probably next to a pond or something. But it did generate a pretty good image. Trying to understand the context. This is from Karnataka, so it actually has an Indian there. And then there's a water. I don't know how it's going to solve the problem. Maybe it looks like he's actually puking water.
Hello. I have a prompt. Yeah. I have a prompt.
Yeah.
Mahatma Gandhi performing quantum computers.
Mahatma Gandhi performing?
Quantum computers.
Mahatma Gandhi playing with quantum computers or working on quantum computers?
Performing actually.
Gandhi is coming up. Let's see how the quantum computer comes. Again, the accuracy of these models also differs from model to model. This specific model that I'm using is pretty good in regenerating human faces. So probably this prompt works best with those kind of things. But there are models specific for specific industry, maybe for healthcare. You might have an healthcare related use case. Maybe you want to generate an X-ray with a broken bone, right, for some training purpose. So you could use actually models that are specific for the training industry, for the healthcare industry, to generate those kind of images.
How many concurrent prompts you can give?
So can you keep it?
How many concurrent prompts you can give?
How many?
Concurrent prompts. This is an application, right? So different users at the same time can.
So like I said, this particular instance is a single socket Xeon. You can run 2, 3. See, again, technically there is no limit. I can have 10 prompts. Only thing is the single prompt almost took. It says 4 seconds, maybe it took around 10 seconds to it to generate the, maybe due to bandwidth, network bandwidth, it took almost 10 seconds.
Any benchmarking,
Definitely there's a lot of benchmarks. I think there are couple of slides in the thing that talks about the benchmarks. There are benchmarks for each of these processors, Xeon, Max series of GPUs, Gaudi. The benchmarks are readily available. How much time it takes for each of those models and what are the performance parameters for those models. Thank you.
Sir, I have a question. Here.
Yeah.
My question is that for the standard machine learning model, we have the efficiency you can measure by AUC or RMSE or confusion matrix, that kind of measures by which we can conclude that how good this model is or not. In the similar fashion, for this kind of LLM, is there any validation processes there, like how?
Yeah. If your question is whether what are the metrics to use to evaluate the
like
performance.
RMSE, in case of regular machine learning model, we have a root mean square error, area under curve, confusion matrix, we just accuracy, recall, precision, and all those things we get considered based on the situation, right?
Yeah.
In LLM models, let it be image creation, let it be, summarize something, let it be any generative AI model, how exactly we measure the efficiency or accuracy of the model?
So there are multiple parameters to measure the efficiency. One of the first parameter is the accuracy of the model. So here it generated an image of...
How will measure the accuracy? Because here basically what happened, we have a training set and we have a testing set. With respect to testing, whatever the output comes, whatever the real data, we make a comparison and come up with that accuracy is 80%, 90% or recall is this much. But here there is nothing called, training data, we don't know. We are simply using the model.
So even here, there's a very similar training data set, right? Say when this model wanted to understand how Gandhi looks like, there are several images of Gandhi, right? There are several images of Gandhi in different poses, actual real images of Gandhi, right? And there are labels attached to each of the image saying that this is Gandhi sitting, this is Gandhi standing, this is Gandhi walking in the Dandi March, and this is Gandhi walking in this Khilafat movement or whatever different types of movements, right? And it will actually, let's assume that we are training a model specifically only on Gandhi. There's no other data set, there's only Gandhi which is being trained upon. If I am using 100 images of Gandhi, it will take, say, 80 images of Gandhi, and it will actually train it up. And then balance 20 images, it will try to see how close it is to the actual image in terms of all the RGB values.
No, finally, I'm not interested in process. My question is that suppose this particular picture you've got, what is the accuracy of that picture? Suppose he is from US, he does not know how does Gandhi look like. So he need a figure to ascertain that whether he can trust this picture or not. In those scenarios, is there any measure or your system, I mean, whatever the demo you are giving, is it giving any numeric value?
So, if I come back again, right, if you remember when the second or third slide where I spoke, where we need to upgrade ourselves, our skills, we need to be experts. Basically, the AI will generate what it can generate. Finally, we need to validate it and tell it. To answer your question, some of the things we have to manually validate. We have to judge it. I can say this is like 50% accurate. Maybe the other person might be saying 80%. It's again judgmental. So based on that, we need to...
There is no scientific validation, manual validation you are saying.
For certain things, right? This again, there are certain things we cannot have a black and white values. It will be different shades of gray. For images and all, there will be different shades of gray, right? If it's a numerical value, if I ask what is 2 plus 2, I know it has to be only 4. It cannot be anything else. If it's anything else apart from 4, that means it's wrong. But for all the other kind, if it's a text, right, I asked, what is the capital of Karnataka? The answer can be Bangalore is the capital of Karnataka, Bengaluru can be capital of Karnataka, or Bendakaluru is capital of Karnataka. These are all the different answers. Again, I will say, like, for me, since I'll say Bangalore is correct word, so I'll give 100% accuracy for Bangalore. Some other person will say Bendakaluru is the correct word because that is the origin of Bangalore, so Bendakaluru is the correct word. So again, it depends on human these things. So it's kind of a shades of gray that you need to evaluate.
Got it.
But for different metrics, there are inference time is one, accuracy is one, and then for large language models, it can be number of tokens it outputs for a given question. So in the actual hands-on demo, I'll show you where you can actually set number of tokens. For example, you will ask a question, right? You ask a question, what's the capital of Karnataka? And you can set how long you want the answer to be. You can set like whether the answer to be precisely in 10 characters or 50 characters or 100 characters. You can set that. That is called tokens. So now what is the input token size and what is the output? Again, models are evaluated on that. For a given input, if you have a question that is almost 10 pages, and what is the answer? So how much time it takes to process a 10-page question and give the answer. So there's also a metric. It's called input token size and output token size. You take those token size and measure it, and then based on the use cases, say for example, if it is in a research industry, right? Where research industry, the questions usually will be huge. For example, let's assume that I'm a patent attorney. I want to check the patent's complete description. So patents questions usually will not be small, right? It will be hugely the complete patent document. It might be running into multiple pages. You take this entire multiple page, feed into it, and then see how much time it takes to respond you back with the answer. So that's actually a metric, that's a performance metric for your particular use case. But for a use case for a school, let's say somebody is building a teacher assistant tool for a school, there might be mostly the questions will be like 1 or 2 lines, and you have answers also within 2-3 lines. Or maybe the question might be one line, write a essay on the history of Karnataka. It's a single line, but you have to write the entire history of Karnataka beginning from the written records till date. So that might be running, the output token might be running into multiple like 10,000 tokens or 1 lakh tokens, right? Again, based on the use case, it differs. You as the guy who is working on this model, selecting the model, they have to decide which is the metric that is best suitable for your use case.
Thank you.
Yeah.
Hello. For the given prompt, can I say like Mahatma Gandhi is one parameter, working is the second parameter, quantum is the third parameter, and computer is the fourth parameter?
Yes, that's how actually internally it works, right? When you give this prompt, each word is taken as one particular thing. It will actually rank it. It will convert that entire text, human readable text, into a matrix multiplication, matrix with the words and the rankings for that, and then compare against its internal database and see which one actually matches that. And I mean, this is the simplest form. It's not exactly that way, but it's the simplest form of explaining it.
Okay, so if I give some parameter which does not exist, so it will not be able to generate that
Probably
image.
if you give a parameter which it hasn't seen it altogether, we'll see in the actual hands-on demo.
Yeah.
Where
Can we change it to Mahatma Nehru Gandhi and see what will
let's
happen?
say let's use a wrong word for Gandhi. Instead of maybe Nehru is also actually
because
correct
Nehru don't have surname of Gandhi, right?
It might actually, let's see, it is probably it might come something similar to this, because again Mahatma, Nehru and Gandhi are all again actually a word that exists. Probably let's use a word that never existed.
Okay.
Let's misspell Gandhi's spelling, right?
Sure.
I misspelled the Gandhi spelling and tried to see what it generates. If the original training data had this kind of a misspelling, and if it was trained, probably it will understand that Gandhi is also Gandhi. So probably it might also come to this. Probably it's understood that Gandhi is also Gandhi. So it's trying to generate. Maybe you can give me an example of a word that doesn't totally make sense, or a word that didn't exist. I think it understood, probably it's over intelligent, so it's understood that word Gandhi is Gandhi, so it's generating a Gandhi's image. Any questions?
So I have one question, like in basic machine learning, there is a term called underfitting and overfitting of data.
Yes.
So in this LLM model also, while you are training data, it happens that there is an underfitting and overfitting of data. If yes, and how it is getting solved?
So like I said, this particular model that I'm using, Dreamlike Photoreal, this particular model is overfitted for human faces. If you ask it some non-human faces, like say generate a forest scenery, probably it might fail badly, because it's not trained with that kind of model data set. It is very good in generating human faces, this particular model. But there are, like I said, there are models that are specific for healthcare industry, where all the data that is trained is mostly healthcare related things. So it understands that. Underfitting will be like all the non-human faces is an underfitting for this. Anything else? Yeah, can we go back to the slides? Next, I would like to talk about the the Intel Gaudi model migration. Let's assume that you have already have some kind of a model that is developed and targeted as a specific GPUs, and you might want to migrate it to Gaudi for the various reasons. One of the compelling reasons might be it's very cost effective. The performance is equal or better than the GPU that you are using. These are some of the common use cases that we see. In that case, you don't have to actually rewrite all your code. There are tools that are available with 1 or 2 lines of code. You can actually start, say for here, there's an example of how to remove CUDA code. Most of the times, if you are having a GPU, you might be having a CUDA. And you can actually start removing the CUDA code with additional, whatever you see in the blue colored text, these are all the only changes that you might be doing, right? Say for example, in the 4, there is an AutoCAD device type is equal to GPU. Usually it will be GPU. You might want to write it as HPU. HPU stands for Habana Processing Unit. That's actually a code name for the Gaudi AI accelerators. And then you might want to import the Habana frameworks. That's one additional change you might have to do. And then there are certain other functions that you might have to call. These are the only changes that you will do to migrate your CUDA code to the Habana Gaudi AI accelerators. And if you are using GPU toolkit, it's only 2 steps. Just write whatever the text that is there in the blue color, and just include those, import those libraries, and add only those 2 function calls. With these 2 steps, your entire CUDA code is migrated to the Habana Gaudi AI accelerators. Yep. Then probably we can skip this model migration demo. Gaudi on large language models, Hugging Face, I think, how many of you are aware of what is Hugging Face? So Hugging Face is an repository. It's free, something similar to GitHub, but mainly all these AI models and AI related codes and everything is available there. All the models are available there, so you could go to Hugging Face and start downloading different types of both generative AI models as well as classical AI ML models, right? And specifically for the Hugging Face, for the Gaudi, we have the Optimum Habana library that is available on the Hugging Face. You could use that to start working on some of your large language model related use cases. You can run the Hugging Face models. These are the steps. Probably you can take a snap of this. It's also available on the Gaudi tutorials. I'll share the link at the end. Probably you can go to that link and it's available there. All the codes are pretty open source, available on the GitHub for various popular models. It's pretty easy to use, get it up and running. These are some of the parameters you might be wanted to set specifically for the Gaudi AI accelerator, like the highlighted one, the bfloat16 is the data type we want to use. You also want to use the HPU graphs as well as the Habana framework. From the roadmap perspective, Gaudi 1 was released some 2 years back. We are currently in Gaudi2. Gaudi2 is already available in the market. It's Gaudi 1 is available both on the as an on-prem machine as well as on the AWS. Gaudi2 is currently available either as on-prem or on the Intel Developer Cloud. And we have plans by end of 2024, we should have Gaudi 3. And then there's also plan for the next generation of Gaudi accelerators by 2025. So these are again some of the reference materials, links. Probably again I'll share these links at the end of this presentation. Now let's jump into, we talked about all the Gaudi AI accelerators. Now let's jump into Xeons and GPU and CPUs. So from an AI software perspective for GPUs and CPUs, we, like I said, Intel has been working extensively on all the open source libraries and frameworks that are like Pandas, PyTorch, TensorFlow, XGBoost, Intel Neural Compressor, and other tools that are readily available for you to enhance your productivity and enhance the performance of your AI applications. And all these are open source and it comes under the bracket called One API. And One API is all open source. And so one good thing about One API when you compare to the competition is One API is hardware agnostic. It can run on Intel hardware. It can be CPU, GPU, or FPGA, or it can also run on the competing hardware as well. It's not tied to particular hardware vendor. There's no vendor lock-in. And then we have an OpenVINO. OpenVINO is also a framework from Intel that is used for deep learning applications. You can actually use to do the inferencing or optimization of your models. You can use the OpenVINO toolset. And the One API Analytics Toolkit that I said covers all the things that is required for specifically for the AI deep learning things, both classical AI ML as well as the deep learning AI models. It has everything that you could popularly think of. It has all those tools and libraries that are specifically optimized for Intel hardware. The guarantee you get with using One API is your code is hardware agnostic. The moment you develop your AI solutions using One API standards, it automatically becomes hardware agnostic. It can run on any of the Intel's hardware, or it can run even on the competing hardware. So tomorrow if you want to move from CPU to, maybe you want to do the product POC or the development on CPU and deploy it on GPU, you don't have to do any code changes. You can directly do the migration. And from a software portfolio perspective, we have again all these different some of the things that probably you might have want to be aware of is the Intel Neural Compressor, and we have solutions for cloud, enterprise, the client workstations, or even on the edge. There are also some paid tools like Getty. Getty is used for annotation or training of your AI workloads. There's Converse.io, that is again a paid tool that is mainly for MLOps. If you want to build an MLOps pipeline, you could use Converse.io. Then you have Hugging Face, where Intel does a lot of optimizations of the models. And to give you an example, of I talked about Modin, right? So Modin, there's only one line of code change that you do. Very first line, instead of writing it as import pandas as PD, you will write import modin.pandas as PD. That's the only line of code change you do. And suddenly you see the improvement in performance. Pandas took almost 340 seconds to process a 2.4 gigabyte CSV file. But with just one line of code change, suddenly you dropped your performance from 340 seconds to 31 seconds. There's almost 10x improvement in the speed. Then the Intel extension for PyTorch, there's only 2 lines of code change. Whatever you see in the comments section, that's the only 2 lines of code change that you do. With that code change, what happens is it actually goes ahead and uses the AI accelerators available in the Xeon processor, like the AMX AI Accelerator. AMX stands for Advanced Matrix Extension, right? It actually increases the speed of matrix multiplications. And all these generative AI models or AI models are mostly involving extensive complex matrix multiplication. So that actually can be enhanced using the AMX Accelerator that is available in the Xeons. Next, we have the Intel extension for scikit-learn. Again, this is just 2 lines of code change that you see in the green square. That's the only 2 lines of code change that you do, but you get a tremendous improvement in performance of your code. Now let's go to the Intel Developer Cloud. I want everybody to go to cloud.intel.com. Have you created an Intel Developer Cloud account? It's a free account that you need to create. How many of you want to create the accounts? Can everyone go to cloud.intel.com and sign up and create the accounts? We'll get into the last part of this hands-on workshop. We'll get on the actual workshop. We'll do some hard coding. I'll wait for a few 1 or 2 minutes for everyone to sign up and create the account and log in. Krishna, please, can you just verify for me? Standard. You can select as a standard user. How many are yet to log in? Anyone pending login? We can get started. Okay. Meanwhile, if anyone has any questions on whatever things that we discussed so far, I think this is the time to discuss that. How many of you plan to start working on generative AI models on your both personally or professionally? Okay. So if you're working in your enterprise, in your company, if you're working on any of your generative AI models, specific use cases, if you need any help, feel free to contact me. My team will be there to help you. So one of my job responsibilities is to help developers, enterprises, companies to develop their AI solutions right from POC stage or ideation stage to production stage. Your solution might be in between ideation or between ideation to production. At any stage of this development, do feel free to contact us. We will help you on some of the best practices, some of the best tools that you could use to reduce the cost while improving the performance and get best deal out of your existing setup. Everyone logged in? Anyone pending to log in? Okay, sounds like everyone is logged in. Can we switch to the screen again? So once you log in, you will actually land into this page. This is the Intel Developer Cloud. So Intel Developer Cloud is a service from